Okay, so other types of graphs. You have a bar graph. It can be represented by either vertical or horizontal bars. Whose heights or lengths represent the frequencies. So basically a histogram, but it can be vertical or horizontal. And if you guys have ever seen, a lot of times people like to do this where they're comparing and contrasting how quickly things have grown, like the most popular car brand, or how quickly, I think the most recent one I've seen is how quickly certain social medias hit whatever, like 1 million users or whatever. And you'll see, and they'll do it as a time lapse where they're like actively growing and shrinking. That's basically a bar graph that they're using, okay? A Pareto chart. It is using a frequency distribution for a categorical variable, so eye color, okay? Instead of numbers, it's using eye color or car color or something that is not quantitative. The frequencies are displayed by the heights of vertical bars, which are arranged in order from highest to lowest. So that is where you get the difference. So actually, I guess it'd be more accurate to say that what I was just talking about those social media or whatever things, it's using a Pareto chart because every time it gets to be the largest number, it always puts it up on top. So that's what they're using when they're doing that. A time series graph represents data that occur over a specific period of time. That one's pretty obvious. I weirdly enough just looked at one because I was looking at how much what the electricity company said, what my usage has been over the last couple of months, like how high it's been and stuff like that. And I was actually looking at saying, are we like ridiculously off the charts on what we're using on our energy, or are we about where we should be? So I'll compare from last year to see, and actually our electricity company actually tells us, hey, you're using this much percentage more energy since as compared to this time last year. But it's kind of nice because it also gives me temperatures, so I can look and see when the temperature went down. Hopefully that means my energy usage went down, and it generally does. So that kind of stuff is actually really useful in real life stuff, especially when you're talking about like that or something else. A pie graph, another one that you should be very familiar with. It's a circle that is divided into sections or wedges. According to the percentage of frequencies in each category of the distribution. Everyone in here know 100, like you're completely comfortable if I give you a pie chart, you know how to use it, you know how to make it. Yeah, that one, again, it is another one like histograms. You should have known how to do that one from middle school. And then a dot plot is a statistical graph in which data value is plotted as a point or a dot above the horizontal axis. So here are some examples. The top two, that's your, or the top left is your bar graph, a horizontal one. And then B is a Pareto chart. So again, it starts with the largest and then it goes down. You've got a time series. You've got a pie graph. And then this is a dot plot. This is one you may not have seen before. Basically, it puts a line at your x-axis and marks all of your values. And then anytime it's that value, and generally speaking, these are going to be discrete data, not continuous data. You just basically put a mark there so that you can look at this and easily see, oh, this one occurs the most frequently. It looks very similar to a histogram. The difference is you don't group it. It's going to be the individual data points. So obviously, if you have a wide range, you're not going to use that. It doesn't make sense. But if you have like from 40 to 55, that's not too bad. You can plot each of those individual data points. And then the last one is a stem and leaf plot. You may or may not have seen this. It is a data plot that uses part of the data value as the stem and part of the data value as the leaf to form groups or classes. I'm going to be honest, outside of teaching, I've never really seen these. Like, I don't know if there is an actual usage for this, but there may be. I just may not have seen it. But what this is doing is it takes your data here. The tens digit is your stem, and then you list the ones, and you make sure if they repeat that you list all of them in the leaf area. So I can look at this and say 2 is a number. I can say 32 occurred 1, 2, 3, 4 times. So you kind of break it up in that way, and that's helping you look at the numbers and how frequently they occur. Or if you want to group it as in tens from 0 to 9, 10 to 19, etc., you can see without doing anything else, you can easily see that 30 occurs, or the ones in the 30s occur the most. Okay, so that's kind of the purpose. You might see it as a chart. You might see it looking like this, where they just have a line between the tens and the ones. Is that okay? When you're doing this, the ones are in order. So it's numerical order. So that way you can easily, again, that's like, you can see that the twos are all grouped together. All right, and then more about misleading graphs. So we talked about this a little bit. There is the exact same data in both of those graphs. Okay? What's the difference? The Y values. This shows you from 95 to 100 versus this, which shows you from 0 to 100. Left or right, which one is more of an accurate representation of the data? The one on the right. However, if I am this first one and I'm wanting to show you how many more vehicles on the road, I'm going to probably put this one, and if you're not paying attention, you're not going to notice. So it makes it look like their car is more popular when they literally only have 0.5% more. So that's the other thing, is you also have to look. This is not number, this is percentage. So you need to look at all of the things, your scale and what it's representing, in order to determine, is this accurately representing the data, or is this what we call a misuse of statistics?